So we took our persuasion hammer here and we tapped it on the back side, tapped it on the top. A lot of questions, and that's what sucks. When it rains, it pours, and here it is, 7:30 on a 4th of July night. You got more questions than you do answers. Nothing works the way it's supposed to. Compressors keep tripping out. They don't really tell you why they're tripping out. They say short cycle delay, but you don't know if is it that or is it temperature it's acting up or what. It's quite the entanglement we got going on here.
This video is brought to you in part by TruTech Tools. Quality tools, essential support.
Well, happy 4th of July, everybody. It is July 4th, and we are heading to a service call. It is 6:23 in the evening, heading about an hour from home. That's traveling at 75 miles an hour to it. It's a plastic company that I've been at before, and unfortunately, they've got a chiller that's not working very well. I've done a video on this place before. They had plugged up screens. A lot of issues there. I had to change TXVs on one of the other ones. All that stuff's working. However, the one that I'm going to, it's got a problem with the outdoor fans not coming on, which was a problem I had before in the past. Hopefully it's something worthwhile and not just something dumb. All right, so we're here. They've put up some new water towers and stuff. Over here's this condenser, which we got hot air coming out here, but not all the fans are running. So this was a fluster mess the last time. Yeah, that one's cold, so that one's not running. This one here is the variable speed. Looks like they ran some garden hose. I bypassed the contactors the last time. Let's see how the underside looks. Don't look too bad. All right, here. So we had some high pressure problems. Then we had a compressor fault A and B on the 4th. Probably had problems with the fans not running out there. 460 volt, 1, 2, 3, 4. So we'll have to look it up, see what exactly that is. But
they jumped the fans out yesterday, I think.
They got some of them jumped out. There's a few that aren't running out there though. Guess that kind of just makes it easier. That one's not blinking, so we seem to be all right on that. See, I had done some work here on this here because I had to replace these flow switches. So that one over there seems to be all right. So we only got one tripped out right now. So high pressure switch there's okay. Let's see how it is on this other side. What I don't like is if you're going to have your maintenance guy get in my way, and it's like, well, why didn't they just fix it? Okay, looks like we are really cloudy there. It's always nice. How did they bypass it? Do you have any idea on that?
I think they put a jumper out there from one circuit to another.
Yeah, he made it sound like maybe they did it in here.
No, I think they did it out there.
Right now, technically, you have no alarm.
Yeah, circuit one's not on though.
Do we need to turn it on or is it off? There we go. So we do have discharge pressure.
I think it does.
Input, analog inputs. Safe pressure, here we go. Yeah, we're running 450 so far. Okay, so I've got this kid up my butt like a tick, asking 122 questions. I was told something about this was supposedly bypassed on, but the thing tripped out and it's not even running. All the information you're given is wrong. They haven't had me out here for I don't know how many months, and then now all of a sudden you're on call for the holiday and then you got to figure out what's been being done. And supposedly, according to history, somebody had a problem with the solenoid, but they wouldn't let them come out and replace the solenoid because the machine was going to be down for a few hours. So that's the dilemma we're at. Did that even have anything to do with it? Was that even an issue? How did it survive now for almost a month? A lot of questions, and that's what sucks. When it rains, it pours, and here it is, 7:30 on a 4th of July night. You got more questions than you do answers. Nothing works the way it's supposed to. Compressors keep tripping out. They don't really tell you why they're tripping out. They say short cycle delay, but you don't know if is it that or is it temperature it's acting up or what. It's quite the entanglement we got going on here. All right, so we've got a solenoid valve here that's not wanting to open every time from what I've heard in the past. That's liquid line and it was sweating something fierce. Our compressor was going off on number 4, which I just looked it up. That is overheating. So what I was thinking about doing is trying to do manually. But like I said, they didn't want to let us change the valve, so it was acting stupid. I'm gonna see if I can yank it off, maybe get it forced manually open, just keep it open. Well, this is your hot gas bypass going on here. Yeah, that's coming across off of discharge gas line there. So yeah, that's the hot gas there on that other valve here. So we took our persuasion hammer here and we tapped it on the back side, tapped it on the top. I'm looking down here, it's in line with the filter dryer. You've got a solenoid, or you got a actual ball valve right there that you could close. And then if you could drive the EXV closed, you'd be isolated, then you could take it apart. You could recover the refrigerant out of the filter dryer there. It's got a stem on it, you can suck that back into one of the other compressors, but I don't know, why do it now? Let's just do it on the overtime. That's always the best way. And then the part's probably not here. The fan's out there running. Basically all we can do is keep, yeah, compressor 1 anti-cycle. Well, that's because it didn't even come on. It's probably still hot. It can't get cooled down because it's pumping down. So I'm gonna drive this to 0, I'm gonna drive this to 0. I've got all my other valves valved off here. I'm gonna pump that out of there into the receiver and chop this out and then try to go ahead and change it. We got a new valve setting here. So what we're doing, went to manual, so that's on circuit 1. Went to manual, went to 0. Here's the EEV, circuit 1, manual 0. So we've got those there. We've got it also shut off. We've got it disabled there. It's been about 4 or 5 months since I've used this controller. So that's where we're at. Okay, so what we're doing here, we're using the filled piece recovery machine, doing 3/8 line, dumping it into the discharge line, which is going out to the condenser. We're pulling off of the end of the filter dryer. I yanked the valve cores out. One of our guys said it was going to take 4 to 8 hours supposedly to do this. It's not going to take that, and I'm sure as hell not going to be here that long. So we're getting it done. Should have been done through the week, not on overtime. Not when it's something this critical that they're willing to spend stupid money to do this on the weekend. That's just ignoramus. All right, so we went ahead and took this apart. I yanked the bottom out of it too. So we're gonna put all this over here on the clean rack, keep track of it. There's really nothing inside there that's anything major. Chances are one of these plastics, as you can see that mylar plastic there easily could melt. That's why I'm doing what I'm doing. It's got a metal gasket in there, which, you know, whatever. I'd rather take a chance of that gasket not sealing than chance of burning up the valve. I'm good at brazing, but I'm not taking a chance of screwing myself here. So we're gonna mark on there which direction it's going. That way we don't accidentally screw up. Okay, so we made our cut here. Had a little bit of pressure in here. Obviously it wasn't opening up because we ended up having that solenoid on there, magnet on there, and it didn't work. So yeah, that should relieve something inside there. Let the pressure push it one way or the other. Either way, it's junk. Yeah, completely different setup here, completely different. It's got one little mylar plastic piece there, so that pressure comes in, it should push this up. By relieving the pressure on the top there, it should have left it right up, but it didn't. And as you can see there, those shavings even fell down in there anyway. So we'll heat this thing up, pull that thing off. Yeah, 4 hours. Like I said, I've got the kid, he's nice, but man, he makes you nervous after a while. You kind of figured they would have said something. Nope. So I burnt that wire in half. So I've got that patched back together. Got to restart it, pull this other end off, slide this thing together. It's hot. like that. I think we're on.
Yeah, it's just a little tiny bit off. You always have to go in there, and even when it's an auto, take it.
Don't make sure you don't screw with the one on the circuit 1 though.
Yeah. I just did that one.
All right, I think it's safe to go ahead and put it back together. Debating. I think I'm not going to replace the seal. It looks really, really good. See a little copper right there, though. Ooh. They actually look pretty good. They're not even dirty at all. And I don't have 3 of them anyway, so I'm not going to change it. Okay, we wiped everything off. I tried. I only have 2, so I'm not going to change them. And they look really good anyway. It's refrigerant oil. It's called NILOG. A guy that was in the field that liked chemistry basically came up with it, and he says it's his liquid gold because he makes lots of money off of it. All it is refrigerant oil made into a sticky form because it don't hurt nothing. We'll use the torque wrench on it here in a second. That 3/8 really helped out a lot, and yanking the valve cores was another huge difference. Great tools make the job go much easier. TrueTech Tools guys, as usual, they're a big sponsor of my channel. They've been good to me. Fieldpiece has been good to me. Some of the tools I've got from them have been really good. The vacuum pump and the recovery machine have been top notch. This can have some issues in the super hot weather with 410A. But I haven't got to do enough recoveries with it to see whether or not it was just a fluke or, you know what. Well, at least I get a little something, don't I? Ain't much to stare at, but I'm not feeling like using my vacuum pump. We're just going to go just better here, so they say. We're only pulling on that filter section. We've got the solenoid open up over here, so we'll be able to pull through all that. That's why I'm not overly worried or concerned. We're going to go ahead and pull through the valve core tool. You guys know I use the big blue 3/4 inch hoses. It's almost 10 o'clock. All right, so close enough. I guarantee you we valve this off, it's going to start rising just because refrigerant was leaking through when I was pulling a vacuum or bracing it in. So what we're going to do, we're going to go ahead and open up our valves here. And we'll open up the other one. And then we got one more down here. This will be the main filter dryer. And then we'll spray everything and see if we... Ooh, that's a lot. There we go. Now we'll go ahead and take the solenoid. Take the solenoid off. Go ahead and put all this back together. and then we're going to spray it for leaks. Okay, so we got new valve cores. Make old Jim Bergman proud here, because he likes to see you use a new one every time, because they're only a one-time use, which I can kind of see that, but I don't really go with it very often. Okay, we'll spray some bubbles on there. Not seeing any leaking. I just popped that thing off the top of that solenoid there. Just put the screw down on it. Huh? Go ahead. Okay, there's that one. That one's on there. No, we did not use nitrogen on that valve. There was no place to actually run it through. Everything was pretty live. I mean, I may have been able to go through the this part here, but yeah, that one didn't want to come out originally. Gonna bring a new one in there now. Okay, so we've got everything back together. Gonna go back into here.
Turn it on right there.
I got to go back in there and actually tell it that one spot. I need
That's the right spot.
Well, yeah, I got multiple things I got to switch up. Yeah, but I got to put my. Here we go.
Put it manual.
Yeah, I want to put that back to auto. That is for the superheat, which we got it set for 10. Then we got hot gas in here. We'll put that back to auto. Alarm shut down. Well, circuit 1. So 380. Suction, we're running at 44 degrees saturated. Superheat so far is 32. EXV's at 50%, so doing pretty good. Compressor 1A is short cycling a little bit, and B both, but I don't know what they're complaining about. Running 440 on the head pressure there. We're kind of getting up there. 18 degrees subcooling, that's on circuit 2. That's 1A, 1B, they're running. Yeah, they're running, buddy. Yeah, they're running, they're hot. These are running too. Yeah, because you know, down here at the end, you've got one that is variable speed. Yeah, this one's your variable speed. See, and say over there too. See how it's got heat sinks right there?
Yeah.
So that's a variable speed, meaning it'll speed up and slow down. That way you're not cycling the fan completely on and off. So if it needs a whole one, it tries to keep the one on all the time, and then this one will go up and down. If it still ain't, you know, then it bounces back and forth. Well, it's warm, and that's warm. So across my valve is good. So we are good. Did you lower it down?
We got a 55.
Okay, yeah.
It was down, it kicked that one. It took these two compressors.
Run it down to 50. Let's make it haul ass. I want to see it screw up while I'm here. I don't want it to screw up after I get halfway home. I'm an hour drive away. I don't like seeing this stuff off. I mean, it may not be 460 volt here, but I don't like that. Looks like it might need a little bit of refrigerant. The other side, it's got some haywire stuff too. Let's look at the subcooling on this. High fluid temperature, okay, because we lowered it so much. So it's a warning, though. Process supplies at 61, return, so we got a 6 degree, circuit demand 90% running. So far so good. We're running 17 degrees subcooling. Superheat's 12. I don't know, I guess I'm not gonna jump the gun. I'm gonna leave it alone. So our EXV is at 52%, superheat's at 14, 25 degree subcooling. I suppose that could be from a dirty coil. Liquid refrigerant's running right in at 96, so I mean, that's not horrible. Might push that superheat back down a little more, that way we get those compressors a little bit. See, I don't understand why this is so much different. I ain't got time to read through the book right now, so put it back to 10. Usually we run them at 9, so it depends on how accurate. Oh, it won't go below 10. I put 9 in there, 9.0. Yeah, it moved it up to 10, so that's as good as you can get. So they must not want it very low. Oh yeah, that's pretty cool right there. That's great. Same here. So these shouldn't be tripping out. See how this other one. They're running a lot cooler now with that lower superheat. Yeah, these ones here. So this thing just alarmed. This is their water. If you remember, this thing looked really, really bad the other day. Ugh. You can see it over there. They finally got something to treat it. So they've got chemicals down there. So they're finally doing something to make it better. And then all these lines go across. The video you've seen before, well, I think I had a problem with that. I got that fixed. I need to take this back. This is my stethoscope. I couldn't hear it clicking, so I was using that. I got that all tucked back in. We're good to go there. I think we're about done. So this one's doing really good. And these are those valves that I changed the other time. And it seems to be doing good. Remember I had 7 to 11 is what I set. This one here played a lot of games with me. I think it's just because these are such a large valve is why those things flash like they do. And you know, when the subcooling's telling me we're high, and which is telling us that we're backing up refrigerant into our receiver here, and then, well, yeah, or condenser, I should say, and that everything's looking good. Plus, you can see your oil levels here. So we're not flooding into that. The other ones look pretty good too, so we're good on that. I think we're done, guys. All right, I think we're gonna wrap things up. If you guys enjoyed the video and you want to see more like it, please subscribe. Make sure you hit the like button. Leave me a comment down below. Hope you guys had a great 4th of July. Until next time, later. I don't know, guys. I talked to the kid more. He's 23, 24, and the more we talked, the more I started to like him. It's just one of them things where you're under stress and you want to get things done. And, you know, I like helping the younger guys because I had such a hard time when I started. My personality isn't perceived very well, and so I had a harder time. And that's the reason why I know what it's like to be treated bad and stuff. And, you know, even this late in the game, there's times where you get treated kind of crappy like that. So that's a lot of the reason why I make these videos. That, and I just like hearing that I've helped people. It makes you feel good. You make money, but you really ain't making big bucks. I mean, not compared to what I could make if I was just working. Anyhow, we're heading home. Hope you guys enjoyed the video. It's definitely difficult to, yeah, people are getting home. The Ring cameras are going off. But yeah, I mean, main thing was just wanting to see the grandkid. So it's his first year, get to see fireworks and stuff, and I would like to have seen that. So that upsets me the most. Grand total with my drive time and everything, I'll have 6 hours and a quarter, and that's 2 hours of driving. So I did this whole job in 4 hours, but that was diagnosing it and everything else. Anyhow, I need a snack or something. I'm kind of hungry, and time to go home. Till next time. Well, later. Uh-oh.